Okay, so in this video, I'm going to review all the things that you need to know for your Chapter 8 test, which is Friday. I'm going to review the different types of problems which you have in your worksheet packet given to you either Tuesday or Wednesday, and review the different rules to look for and how to look for specific directions out as to how to solve the problems. So in the first section, they tell us to find the missing side of each triangle, and we need to leave our answers in simplest radical form. So in number 4, if you look at that picture, I know we've talked about all kinds of different ways to solve problems. We've done Pythagorean theorem, we've used special right triangles, and we've done trig. So at this point, you may be wondering, how in the world do I solve it? How do I know what to look for? Well, in number 4, they give you 2 of the 3 sides. Anytime we know we have a right triangle and they give us 2 of the 3 sides of the triangle, we can use Pythagorean theorem. A squared plus b squared equals c squared. Remember that c is always your hypotenuse. It's always across from the right angle. So if I plug my information in, x squared plus 6 squared equals 16 squared, I simplify everything. I subtract 36 on both sides. And I get to this point where x squared equals 220. Okay, this is where a lot of you are still having trouble. You just need to keep practicing, watch the videos that are on my website, come get help. You're always looking for perfect square factors from the number. So if I look for factors of 220, notice I always keep everything in my radical until I can actually take the square root of something. I'm going to divide the number by 2. When I divide 220 by 2, I get 2 and 1/10. Well, neither one of those are perfect squares, so those numbers do not do me any good. If I divide 220 by 3, I get a fraction. That doesn't do me any good either. So then I move on to dividing by 4. 4 and 55 work. Well, 4 is a perfect square. If I put the square root of 4 in my calculator, it's going to give me 2. No radical, no decimal. Once I take the square root, I'm done. 55, if I take the square root of 55 in my calculator, that's going to give me a decimal. That means it is not perfect. And I know that the factors of 55 are 5 and 11, neither of which are perfect squares. So my final answer for x is 2 root 55. The next type of problem I come to asks me to state if the 3 side lengths form a right triangle. Now, what you have to do with this, we're still using our Pythagorean theorem. And I know if this side equals this side, then it does indeed form a right triangle. So the question you may have now is, how do I know which of these is the biggest? I am going to use my calculator to tell me approximately what the square root of 212 is. And it's about 14.6. Then I'm going to do the same thing with the square root of 17, and I get 4.1. So looking at all 3 of these numbers, this has to be my biggest number. So that has to go into the C spot. So then I plug in 212 squared and root 17 squared. The square root of 212 squared is just 212. Square root of 17 squared is just 17. 15 squared, oops, that would be 16 squared. 15 squared is 225. So then I want to figure out what the relationship is. So I add 212 and 17. Sorry. And I get 229. On the right side I have 225. Well, 229 does not equal 225. In fact, it is greater than. So no, it does not form a right triangle. In the next set of problems we're going to do, we're going to talk about what kind of triangle it actually forms. But right now we just want to worry about, does it actually form a right triangle? If it's not equal, then it's a no. So in the next set, we have the question asking, is it acute? Is it right? Is it obtuse? We are still going to use our a squared plus b squared and our c squared, but we want to figure out the relationship. If a squared plus b squared is greater, it's got to be acute. If a squared plus b squared is less than c squared, it's obtuse. And we know from the last set of problems that if they are equal, it is right. Now, fortunately, all of these numbers are nice, pretty whole numbers. If they weren't, if I had radicals, I'd plug them into my calculator again to see which one is the biggest. 13 is obviously the biggest number. So I'm going to do 12 and 6 as A and B. 13 is C. If I do 12 squared plus 6 squared, I get 180. 13 squared gives me 169. I know that that is greater, therefore this forms an acute triangle. Next set we're going to do obviously deals with special right triangles. You've only got one side, you've got an angle marked, and you have a side. The directions say find the missing side lengths. Leave your answers as radicals in simplest form. This is a clue that we're definitely not using trig. When we use trig, we get decimal answers. When you use special right triangles, we're going to have simplified radical answers. So here on number 28, I have a 30, 60, 90 triangle, and they give me the hypotenuse. Okay? So I know that my rule in a 30, 60, 90 is if I divide the hypotenuse by 2, that gives me the short leg, which is y. So y has to be 4. To get to the long leg from the short leg, all I do is take my short leg, multiply it by root 3. This is one of the easiest 30, 60, 90s that you could get. Let's look at the next problem, 32. In this picture, they're giving us the side that's across from the 30-degree angle, therefore they're giving me the short leg. My rule is to take the short leg to get to hypotenuse. I'm going to multiply it by 2. Okay, these numbers are the only two numbers that can be multiplied together. You're only doubling the outside number. So u has to be 6 root 2, because 3 root 2 times 2 is just 6 root 2. To get to the long leg, your rule is to take your short leg and multiply by root 3. Well, just like in this problem, you could only multiply the 3 and the 2. In this problem, you can only multiply the numbers that are in the radicals. So I'm going to multiply root 2 and root 3, and I get 3 root 6. Now that number can't be simplified anymore because the only factors of 6 are 3 and 2. Neither one of those are perfect, so that would be my final answer. Now on these problems, you really just have to memorize the rules. You've got to get them in your head, make flashcards, do lots of practice in order to be able to do these. Now let's look at two 45, 45, 90 triangles. 29, so 45, 45, 90. I know that the legs have to be the same, so V has to be 2 root 2 also. My rule is to go from a short leg to the hypotenuse. I have to take my short leg and I multiply it by root 2. So the 2 stays on the outside until it has something to multiply with. When I multiply root 2 times root 2, well, that's root 4. Root 4, if I take the square root of 4, is 2, just simplifies to 4. So u has to be 4. On 37, they're giving me the hypotenuse. So this time, instead of multiplying by root 2, I'm going to divide by root 2. So I take 4, divide it by root 2. When you're dividing by a radical, this is where you have to do the rationalizing thing that we talked about in class. So to get rid of the root 2 in the bottom, I have to multiply bottom and top by root 2. Okay, I'm going to go straight across. I get 4 root 2. In the denominator, I'm going to get root 4, which just simplifies to 2. When I simplify that, 4 divided by 2 gives me 2 root 2. That's the answer for both of my legs.